Okay, here's some notes on solving quadratic equations, and I call this quadratic equations A. We may do a couple videos, and we'll see what goes. And I want you to remember that this is the simplest quadratic equation, and this is actually a kind of a rule. If x squared equals a, or if something squared equals a, then in this case x or that something equals plus or minus the square root of a. All right? That means if I multiply the square root of a times the square root of a, I get a. If I multiply negative the square root of a times negative the square root of a, I get a. So that's almost a rule, okay? So we use that a lot. And now let's take a look at a quadratic equation. This is probably our simplest quadratic equation. X squared equals 4. And I just follow this rule. I say if x squared equals 4, I know that x equals plus or minus the square root of 4. And what's the square root of 4? 2, so that equals plus or minus 2. All right, so that's pretty easy. Let's try another one. Example 2. Let's say x squared minus 6 equals 0. And it could be some number. We could add it, whatever. Okay, well, we want to get to this point where we have x squared equals something. So what I'll do is I'll just add 6 to both sides. And I have x squared on the left equals 6. And then I apply my rule over here. If x squared equals 6, then x equals plus or minus the square root of 6. Okay? And we can leave that like that. Now, we've done some approximations. We'll talk about that later. But you can approximate that and get a decimal value. But let's leave it like that for now. Let's not get too complicated at first. Okay? All right, here's another quadratic equation, simple one. Equals 0, and it could be a number, it doesn't really matter. We'll have to simplify it first, so we want to get this x squared all by itself. Okay? So I'll subtract 2 from both sides. And I get x squared equals negative 2. And remember, if x squared equals negative 2, I know from my rule, x equals plus or minus the square root of negative 2. But remember, if we've got a negative under the radical, we take that out as I. So that means that x is going to equal plus or minus I times the square root of 2. Or you could write it as the square root of 2 times I, but we usually like to write the I in front so we don't confuse whether the I is under the radical or behind it. But you could write it like this in complex form. It would be more correct to write it as, and put the I over there, and that's your imaginary part. You have no pure real part, but you've got a pure imaginary part over here. Okay? That's number 3. And then number 4. X minus 5 squared. So now we got a binomial squared equals 7. So we get down to a point like this in a quadratic equation after some simplifying, etc. We're just going to apply this rule again. If something squared equals a, that something equals plus or minus the square root of a. So in this case, my something is x minus 5. Oh, I don't need the parenthesis there. X minus 5. Get rid of that. There we go. So x minus 5 equals plus or minus the square root of 7. If x minus 5 squared equals 7, x minus 5 equals plus or minus the square root of 7. And then I can just add 5 to both sides. And x will equal 5 plus or minus the square root of 7. Okay. Now we can do some approximations on these because we could actually get a decimal value of this. It's not too hard. We know that the square root of 7 is between the square root of 4. So I'll do it over here, the square root of 4 is equal to 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, and the square root of 9 is equal to 3. So I'll look over there. Now, where's the square root of 7? The square root of 7 is over here. Now, let's see how many increments do we have. Oh, that's not 3. There we go. Excuse me. Square root of 4 equals 2. Pardon me. Went backwards. Okay? So the square root of 4 is equal to 2. The square root of 5, 6, 7, 8, 9. So 7's in between here. Now, how many units do I have, or how many increments do I have between the square root of 4 and the square root of 9? I have 1, 2, 3, 4, 5. What's half of 5? 2.5. So if I go 1, 2.5, it looks like I'm right over here. That's 2.5. So since 7's a little above, this would be 2.5. So I'll say that's going to be approximately 2.6. And if you kind of look that up in your calculator, you're going to find that that's a pretty good approximation. So the square root of 7 is approximately 2.6. So again, we know that the square root of 7 is between the square root of 4, which is a perfect square, and the square root of 9, which is a perfect square. So we can kind of, we call this kind of interpolating. So we could say that x equals, myself a little more room here. So x equals 5 plus the square root of 7, which is approximately, and I put a little approximation there, 5 plus 2.6, which is equal to 7.6, or x equals 5 minus the square root of 7, which is approximately 5 minus 2.6, and that equals about 2.4. So those are some approximate values there. 7.6 and 2.4. If you work those out on your calculator, it'd be pretty close, at least to a tenth. Okay? So that's how we can kind of interpolate. Okay? Square root of 4. I don't know why I put the square root of 3 there. Okay? Square root of 4, 5, 6, 7, 8, 9. And the reason why we pick those numbers is because we know the square root of 4 is 2 and the square root of 9 is 3. So the square root of 7 has to be somewhere between the square root of 4 and the square root of 9. Okay? And we'll do some more in just a moment.